Hello scholars, welcome. Mr. Hinkle here. Let's talk about geologic faults. That's what we're doing. We're introducing various types of faults with examples. So faults are where the rocks break. Okay, what are we talking about? Geologic structures in Earth's crust. And when regional stress forces over an area are applied due to plate tectonics, a couple things can happen. Well, a few. The rocks can change their shape and reverse back. The rocks can bend, or the rocks can break. We're talking about folds when they bend, ductile deformation, and faults where the rocks break, brittle deformation, causing displacement. So here you can see the colorful rock layers in here. This is an aerial view. And then you see the trace of a line that cuts right through the two of them. Let's use this reddish bed. Steno's principles of stratigraphy allow us to understand that this layer was originally continuous. So this layer here, chung, 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 punctuated by this fault that goes through here and continues. The movement of faults can be dip slip, which is vertical, strike slip, which is horizontal, or a little bit of both. Let's talk about the faults that we get. But first, in order to understand fault movement, we need to have terminology. I'm going to make a block diagram and give us two pieces. Whoop. But let me make sure that I'm teaching it correctly. The foot wall and the hanging wall. So I think of these as the foot wall is like shoving your foot underneath of the opposing block, and the hanging wall, it's kind of like you take your hands and you're hanging on to the fault. So we have the foot wall, the hanging wall. These are both blocks. Here's going to be the fault trace, or the fault plane that goes through. Now, dip-slip motion is going to be where you have a relative up or down. It's at an angle of the movement. And dip-slip motion has two different types of faults. Normal and reverse. And we differentiate the two by the direction of movement of the hanging wall with the foot wall. Normal faults are where the hanging wall drops down lower to the foot wall. So you can see do foot and then hanging wall drops down lower to the foot wall. Here, person for scale, marker bed. This was laterally continuous. This is the foot wall. This is the hanging wall. And the fault traces through. There's a little bit of orangish color, some weathering, iron oxidation happening where the rocks have been broken up due to the fault. So we get these commonly because of tension. The stress that is being applied is tension, and the resulting strain is brittle deformation that causes a normal fault to occur. Now, normal faults can often happen in pairs. You have regional extension, where in order to fill up the space from the thinning and the stretching, opposing normal faults will occur, and we can see it here. Let's use this bed. There's a fault. There it goes. There's a fault. So the fault is here and here. Opposing normal faults in response to regional stress, tension, resulting in brittle deformation of faults. So the basin range covers a large area of the Southwest, and it is in this area, it's called the basin range because you have ranges or ridges and basins in between. Now this is large scale. What we see here, this is small scale. Here's a person. This is regional scale brittle deformation, where you have Horsts and grabens, the horsts are the uplifted fault blocks and the grabens are the down-faulted blocks that create ridges and valleys. And this is the topography of the Basin and Range province that covers a good chunk of North America. It's the result of extensional tectonics or tension because of crustal thinning. Cool! We're understanding the way the world looks through the lens of geology. I love that. Okay, so let's keep going. Reverse faults now are going to be where the hanging wall moves up relative to the footwall. Here's our marker bed. Here it continues, and you can see hanging wall has moved up relative to the footwall. This results from compressional forces that shorten and thicken the rock layer. Special cases abound. So low angle reverse faults are called thrust faults, and we often see thrust faults at convergent plate tectonic boundaries. These create big earthquakes. They hold a lot of pressure, they're very deep, and when they release, the earthquakes can be massive. So these subduction zone low angle reverse faults are often called mega thrust faults, and these are the biggest earthquakes that the Earth can experience. Strike slip is horizontal movement with no vertical movement. So this is when one block of rock slides past another. The regional stress is going to be shear stress. This is the San Andreas Fault. Here's a creek that all of a sudden just jumps over and then continues. It's not up or down, it's just side to side. And so strike slip faults have vertical fault planes, but there's no vertical movement. The movement is horizontal. Special shout out. What about when the rock breaks but it doesn't move? It just ka-chunk breaks. Well, this is called a joint. Fractures or cracks in Earth's crust with no movement. That is the main difference between a fault and a joint. So sometimes rocks have big breaks in them, fractures or joints, but that's all it is. It's a volumetric change when the rock changed shape, or the pressure allowed the regional forces just had ka-chunk the rock to break. Other times the rock breaks and there's movement. When a rock breaks with no movement, it's called a joint. When a rock breaks with movement, it's called a fault. So here is our big review slide. We move over here. This is a little bit different than the examples I've given. Now, the hanging wall is on the left, footwall is on the right. Hanging wall low relative to footwall, normal faults. Over here, hanging wall high relative to footwall, reverse faults. Vertical fault, horizontal movement, strike slip fault. So faulting is a result of brittle deformation in response to regional stresses applied to crustal rocks. They come in three different types, or I guess you could say two: vertical movement or horizontal movement, giving us three types: vertical movement, reverse, or normal. Horizontal movement will be our strike slip. So this is our intro into geologic faults. Thank you so much.